Good day, this is Professor Will, CBMD PhD. Today's Thursday, March 25th, 2021. It is 2:42 and 6 seconds p.m. Eastern Standard Time. Today's research, machine learning. So let's hop to it here. Researchers enhance quantum machine learning algorithms. Date March 16, 2021. Source, Florida State University. Summary. Researchers found a way to automatically infer parameters used in an important quantum Boltzmann machine algorithm for machine learning applications. The work can help build artificial neural networks that can be used for training computers to solve complicated, interconnected problems like image recognition, drug discovery, and the creation of new materials. There is a belief that quantum computing, as it comes online and grows in computational power, can provide you with some new tools. But figuring out how to program it and how to apply it in certain applications is a big question. Quantum qubits, like binary bits in a standard computer, can exist in more than one state at a time, a concept known as superposition. Measuring the state of a quantum bit, or qubit, causes it to lose that special state. So quantum computers work by calculating the probability of a qubit state before it is observed. Specialized quantum computers, known as quantum annealers, are one tool for doing this type of computing. They work by representing each state of a qubit as an energy level. The lowest energy state among its qubits gives a solution to a problem. The result is a machine that can handle complicated, interconnected systems that would take a regular computer a very long time to calculate, like building a neural network. One way to build neural networks is by using a restricted Boltzmann machine, an algorithm that uses probability to learn based on inputs given to the network. Researchers found a way to automatically calculate an important parameter associated with effective temperature that is used in that algorithm. Restricted Boltzmann machines typically guess at that parameter instead, which requires testing to confirm and can change whenever the computer is asked to investigate a new problem. That parameter in the model replicates what the quantum annealer is doing. If you can accurately estimate it, you can train your neural network more effectively and use it for predicting things. Good day, this is Professor Will, CBMD PhD, on Advanced Engineering, Computer Science, and Space Technology. This video is strictly made for educational purposes only. Well, hope you enjoyed listening. Until next time, have a great day.